8 weeks ago, 4 astronauts vanished behind the moon. For 40 minutes, every radio signal on Earth tried to reach them. None of them got through. They were 252,000 miles from home, farther than any human has ever been. And what they were photographing on the other side has confused scientists since 1959. Because the back of the moon doesn't look like the moon, it looks like a completely different world. And the reason why, that one is going to mess with you. Think about this for a second. 28 humans ever in the entire history of our species have seen the far side of the moon with their own eyes. 24 of them flew on Apollo. 4 of them just came back from Artemis II. That's it. Fewer people than fit in a high school classroom. Meanwhile, everyone else who ever lived on this planet, every astronomer, every poet, every president, every kid pointing at the night sky, only ever saw the same hemisphere, 4.5 billion years of moon. And we only ever stared at half of it. The other 41% is permanently turned away from us. 0 telescopes can see it. 0 satellites in Earth orbit can see it. The geometry simply doesn't allow it. Scientists assumed for centuries that the far side would basically look like the front. Same craters, same dark patches, same gray rock. They were completely wrong. And the first 6 photographs of it, taken in 1959, broke every assumption they had. Here's the one sentence that explains everything that follows. The moon takes exactly 27.3 days to spin once on its axis, and exactly 27.3 days to orbit the Earth. Those numbers aren't close. They are identical, which means the same face is always pointing at us, forever. It's not the dark side. The far side gets exactly as much sunlight as the side you see. 2 weeks of day, 2 weeks of night, just like ours. Pink Floyd was wrong. There is no dark side of the moon. There's only a side we can't see from Earth, and it has stories on it that nobody told you. 4.5 billion years ago, the moon spun much faster, but Earth's gravity is relentless. Every time the moon rotated, our gravity pulled harder on its near side than its far side, stretching it into an almost imperceptible egg shape. That bulge dragged behind. Earth's gravity dragged it back. Friction converted rotational energy into heat. Over about 100 million years, the moon's spin slowed until rotation and orbit clicked into perfect sync, gravitationally handcuffed, locked, forever. And here's the part most people don't realize. This isn't rare. It's the rule. Almost every large moon in our solar system is tidally locked to its planet. Ganymede, Io, Europa, Titan, all of them showing the same face to their host, forever. Given enough time, billions more years, the moon would eventually do the same thing to Earth. Only half of our planet would ever see the moon again. The other half? Never. The sun will probably swallow us both long before that happens. But the math is real. October 7th, 1959, the middle of the Cold War. A Soviet spacecraft called Luna 3 looped around the moon for the first time in human history. And what was on board this thing is almost unbelievable. Luna 3 didn't transmit digital images. Digital cameras didn't exist yet. It carried actual photographic film, 40 frames, specially treated to survive radiation and the temperature extremes of space. Then, and this part is wild, on board the spacecraft, a miniature chemical lab developed and dried those photos automatically, in space, in 1959. Then it scanned them with a beam of light, converted them to a radio signal, and beamed them back to Earth. 29 grainy frames were transmitted. Only 6 were clear enough to publish. But those 6 frames rewrote what we thought we knew about the moon. Scientists had expected the familiar, those broad, dark plains that make up the man in the moon. What they got instead looked almost nothing like it. The far side was a wasteland of overlapping craters, bright, rough, mountainous, almost no dark patches at all. And because the Soviets got there first, they got to name everything they photographed. That's why the craters on the far side are named after Russian scientists and Soviet space engineers: Tsiolkovsky, Lomonosov, Korolev. The far side of the moon is, in a very literal sense, a Soviet map. It took until Christmas Eve 1968, Apollo 8, for any human to see it with their own eyes. As Frank Borman, Jim Lovell, and Bill Anders orbited just 60 miles above the surface, Anders described what he saw out the window. Quote, "The backside looks like a sand pile my kids have played in for some time. It's all beat up, no definition, just a lot of bumps and holes." Until that moment, no human eye had ever seen this place. Then he summed it up in 23 words. Since 2009, NASA's Lunar Reconnaissance Orbiter has been mapping the far side in extraordinary detail. And here is what it confirmed. The two sides of the moon don't just look different. They are built differently. The side you see every night is roughly a third covered in what are called maria, those dark, flat plains. They're ancient lava. Billions of years ago, asteroid impacts punched through the crust, magma welled up, flooded the basins, cooled, and stayed. That's the face of the man in the moon. Ancient lava plains. The far side, less than 2% maria, almost zero lava. Just an endless field of overlapping craters all the way to the horizon. The most dramatic feature over there is the South Pole Aitken Basin, 1,600 miles across, 5 miles deep, the largest impact crater in the entire solar system. You could drop Mount Everest into it and still have room to spare. And in 2019, scientists looking at gravity data found something buried under it, a mass roughly 5 times larger than the big island of Hawaii, hundreds of miles down, just sitting there in the moon's mantle. The leading theory, it's the metallic core of the asteroid that punched the crater 4 billion years ago, still embedded in the moon. And then there's the crust itself. When NASA's Grail mission measured the moon's gravitational field in 2012, it revealed something nobody had fully appreciated. The far side's crust is significantly thicker than the near side, around 20 kilometers thicker on average. Same moon, completely different architecture. The best explanation goes back to the very beginning. Right after the moon formed, both it and Earth were still molten. The Earth's surface around 2,000 degrees Celsius, a glowing furnace hanging right next to the newborn moon. The moon's near side faced that furnace. It stayed hot. The far side faced cold, empty space. It cooled first, so the far side's crust crystallized earlier and grew thicker. Later, when asteroids hammered both sides, the thinner near side crust gave way and magma flooded through. The far side's crust held. No maria, just scars. Which brings us back to April 6th of this year. 4 astronauts, Commander Reed Wiseman, pilot Victor Glover, mission specialist Christina Koch, and Canadian astronaut Jeremy Hansen, were flying inside Orion, the Artemis 2 capsule. Mid-afternoon, Eastern Time, they slipped behind the moon. For the next 40 minutes, the moon's bulk blocked every radio signal between them and Earth, the most isolated humans in history. They photographed the far side, documented ancient lava flows, surface fractures, crater walls, and right around the moment they broke Apollo 13's distance record from Earth, 252,756 miles out, the farthest humans have ever been, Jeremy Hansen got on the radio and asked permission to do something the mission planners hadn't scheduled. Years before the launch, Reed Wiseman's wife Carol had died of cancer. She was 46. She was a pediatric nurse. She left behind their 2 daughters, Ellie and Katie. Christina Koch had had an idea. Hansen had agreed. They had quietly talked to the science team and asked, could they name a small, bright crater on the far side after her? Hansen's words to Mission Control as the 4 of them floated 252,000 miles from Earth. Quote, a number of years ago, we started this journey in our close-knit astronaut family, and we lost a loved one. Her name was Carol, the spouse of Reed, the mother of Katie and Ellie. It's a bright spot on the moon, and we would like to call it Carol. Hay embraced in zero gravity, Wiseman and Koch were wiping tears from their eyes. The crater is officially called Carol. It sits right on the line between the near and far side. Sometimes, depending on where the moon is in its orbit, you can see it from Earth. Sometimes you can't. The far side isn't mysterious anymore. It's been mapped, walked over by spacecraft, photographed by human eyes, but it's becoming valuable for a reason nobody expected: silence. The moon itself acts like a 2,000-mile wall of solid rock, completely shielding the far side from Earth's radio noise. Every cell tower, every TV broadcast, every military radar, all of it stops at the lunar surface, which means the far side is the only place in the inner solar system where you could build a radio telescope with zero human interference. NASA has proposed exactly that, a wire mesh dish over a kilometer wide sitting inside a far side crater, listening for signals from the cosmic dark ages, the era before the first stars formed. From Earth, we can't hear those signals. The noise drowns them out. From the far side, we could finally listen to the universe's first whisper. The moon has been watching us the whole time. Turns out we've only ever been watching half of it back. When Artemis 2 was on the far side, completely unreachable for 40 minutes, the crew said afterwards that none of them have processed what they saw yet. Christina Koch said what struck her wasn't the Earth. It was all the blackness around it. Drop a comment. What do you think was going through their heads in those 40 minutes of silence?